All right, so you are given a drawing here. You've got segment A, B, you got points B and C in between. So that means they're all on the same line. Now you're only told that AB is congruent to segment CD. So looking at this picture, knowing that given information, do you think segment AC is congruent to segment BD? Yeah? Just one yeah?
Yeah.
Yes.
Bunch of yes, okay. So, the idea of this section, a couple of the main things is really, we've been talking about deductive reasoning. Deductive reasoning is making these statements based off of things that are known to be true or accepted to be true. Theorems, postulates, properties. And those are things that are known to be true. And so we're going to make new statements that are going to be true because of those known things, those known properties. Now, this stuff, these kind of problems, this problem here, and the one that I did at the end of the notes with the angles, those are geometric proofs. Those are you guys writing notes?
What?
Like notes to each other?
No.
Oh, why are you using her desk?
Come on, my name is on me.
So you are writing notes to her?
It's not a note. It's not a note.
Really? What is it?
Song. It's a song.
Really?
Yeah.
Would you sing it for us?
No.
Come
Why
on,
not?
do it.
Do the song Truck, yeah.
Nope, but don't. Nope.
You should look. It's a country song.
I do like country.
Yeah, it's called Truck.
Who
Yeah.
sings it?
Tim McGraw.
Really?
It's a really good song.
It sounds terrible. I like Tim McGraw. He's got some good songs, but that one sounds awful.
No, it's good. It's good.
I am recording this, by the way.
What? Oh.
Uh-huh.
My goodness.
So, before I was interrupted by them passing notes,
So this is good.
what we were talking about, the idea of a geometric proof. In all of geometry, it's one of the hardest things there is, right? It requires the most logic, the most forethought, meaning you're starting here, and you've got to come up with all the steps to get to way over here, okay? It takes a lot of thinking and just a lot of work to do. They're tough. That's what we're doing here, okay? If you don't get it now, it's all right. We're going to be working on this for months, if not the whole year, okay? So it's a process. You're going to get used to them eventually. It will become a little bit easier. So, given segment AB is congruent to segment CD, most of you said, yes, I believe AC is congruent to BD. So in your mind, probably very quickly, you just looked at the picture, you made a couple connections real quick and said, yeah, I think so. So anybody that said yeah, want to explain what you did, what your mind said, or why your mind said yes?
Because it's AC, it's the same as subtracting CD from AD, and then BD would just be well, you know that AB and CD are the same.
Uh-huh.
So you know if you take AC and you subtract it from the whole. Miles, please be quiet.
I see where you're going. Okay, go ahead. Go ahead.
And you subtract it from AD, it'll equal the same thing because when you subtract ED from the whole thing, you still have a congruent piece still left over.
Okay. There's an easier way.
Yeah.
We'll hold that off for a little bit. Okay? I see what's going, and you're correct. There's an easier way. Other connections somebody made to say, yes, I believe this is true.
Because if you know that AB and CD are congruent, you know that, I forget which postulate it is, but like, if you add the same number to both sides, it's still going to say
So what are you adding to both things here? What are you adding to AB and to CD?
BC.
Okay. So what happens if you take segment BC and add it to AB? What do you get? AC. What if you took BC and added it to CD? What do you get? Okay. Well, there you go. So your mind saw that and said, yeah, I think this is going to be true. The tough part is this, putting it into writing. Okay? We always start with whatever we're given. That's the only stuff we know is true. Okay, why is this true? Good. And like I said, we're making statements. We gotta be able to justify it and say, here's the reason why this thing is true. We know AB is congruent to CD, well, because it's given to us. That's the only thing that we know is true. So, like Phoebe said is, you take AB, you add segment BC to it, you'll get something. But what we're doing is adding this segment BC, oops, not to CD, CD. We had equal things, we're adding the same thing to both sides. So what property says you can add the same thing to both sides of an equal sign? It's just the addition, not postulate, but addition property of equality. That's the property that you always use in algebra. If you got two things equal on one side, you add a number to both sides, everything stays equal, right? So, the next thing that we talked about was, all right, if you take AB and add it to BC, what was it that we got? AC. Why is that true? Because what? They do, but that's not the right reason.
Pythagorean theorem.
No, we don't have a right triangle. That's the only thing Pythagorean can go.
Segment addition property.
Oh, so close. It's a postulate. Segment addition postulate. B is between A and C, meaning they're on the same line. You take AB, you add it to BC, you get the whole thing of AC. Okay? Segment addition postulate. That's why we can make this statement. Postulates are something that is accepted to be true. We made a statement using that postulate, so this is a true statement. All right, we also have BC plus CD. What did we get when we added those two? BD. Why is that true? It's same reasoning. Okay. What these things are, this whole problem, is an argument. You only have certain things to start with. That's the given information. You are trying to show, it's an arrow, bad arrow, we're trying to show that AC is congruent to BD. So if you're making an argument, you're trying to prove something to somebody, you're going to have all these steps that say, because of this, because of that, because of this. That's this stuff. But your last statement should always be, this is what I'm trying to show you. This should be your last statement. AC congruent to BD. Do we have that? And do we have the ability to make the connection with what we've thrown out there already? You're shaking your head, yeah? What can we do? If not, I'm sorry, Mason, you're shaking your head.
I can see the connection, but I don't see the stack thing on
Okay. Anybody? Yes. Anna?
Okay, so you have to substitute AC, like, you know, like how you solve it, like AB plus, yeah, that one.
Uh-huh.
In the original, show AC.
Well, not there, but right here. If we take AB plus BC, which is what we have here, we know that AB plus BC equals AC, right? Here's AB plus BC. Take this out and replace it with AC. Then we had a congruence sign. What could we take, if we took this out, what would we replace it with? BD. Because we just made that statement, BC plus CD equals BD. That's what we were trying to show. Why is this a true statement? What did we just do? Substitution. And it is a property of equality. Substitution property basically just means take something out, replace it with what that something was equal to. And that's what we did. There's what we wanted to show. So this thing is done. Any questions about this?